Now we'll look at some examples of quadratic graphs. Quadratic graphs are any graphs that have x to the second power somewhere in the function. We'll also specify that quadratic graphs have second power as the highest power in the function. Now notice the shape that this makes on the graph is a curved line, which we call a parabola. We'll cover more about parabolas in the next unit. For now, let's analyze the domain. Notice that on the left side of this parabola, we have an arrow pointed diagonally upward and left. Now, remember when we look at the domain, we are only looking at the x-axis, and so we'll just note at this time that we do have a left arrow. We know that left arrows represent negative infinity. We also have a right arrow on the other side. We know right arrows represent positive infinity. Therefore, our domain is negative infinity to infinity, as it was with both constant functions and linear functions. However, the range for quadratic graphs is different from what we've covered previously. If we examine the y-axis, notice that we still have two up arrows. Now, the number of arrows isn't that important. The fact that we have up arrows at all means that positive infinity is going to be involved in our range. However, if we look at this curve, we can see that it has a bottom at this red dot that I'm drawing. You can think of this position where I've drawn this dot as the minimum of the function. Now, if we read that position on the y-axis, we can see that minimum is 0. So our range will not be negative infinity to infinity because there is no down arrow, but there is an up arrow. When you're writing the range of a quadratic function, the minimum value is going to be the lowest number in the range. When we write this, we'll write this with a square bracket, and we'll note that the minimum is 0. That will be our lowest y. If we look at the picture, we can see the graph doesn't go any lower than that. But since we have up arrows in our graph, that range will go upward indefinitely toward positive infinity. Therefore, we write our range as 0 to infinity with 0 in a square bracket and the infinity in a parentheses. Once again, we'll try to find f at 2. I'm circling in green where x is 2. We will draw a dotted line upward and place a dot at the position where the 2 crosses the graph, and we read the y-axis. We can see on the y-axis we have a y value of 4. Therefore, we'll say f at 2 will equal 4. If we examine our other graph, you can see we have a different kind of parabola. The reason why we have that different type of parabola is because of the negative sign in front of the x squared. That negative sign will invert the parabola. You may notice that this parabola opens downward rather than upward. And also, it has a peak rather than a valley. You can think of this peak as a maximum. However, first let's look at the domain. For our domain, notice that we still have a left arrow and a right arrow, which I'm circling in red now. Because we have a left arrow and a right arrow, our domain is still the same. In fact, this will always be the same for a quadratic graph. Because of those left and right arrows, our domain is still negative infinity to infinity. Now let's have a look at our range. Notice that we do have downward facing arrows for our range. And when we're talking about range, down arrows represent negative infinity. However, since we do have a maximum, that maximum at the top where I've placed the red dot denotes the highest part of the range. we'll need to read the y value at that position, and we can see that dot I've placed is at 2. Therefore, for our range, to represent the down arrow, I'll write negative infinity, and for the peak, which is the maximum, I will write a 2 and a square bracket. Now for the question f at 2, let's circle where 2 is on the x-axis, draw a dotted line downward, and then read the y value where that crosses the graph. The y value, we can see, is negative 2, so f at 2 will equal negative 2. So this is how we find domain and range for and evaluate quadratic graphs.